Okay, so here's example 9 with the chain rule, and it's not going to be a pretty one. S of t equals negative cosecant of natural log of t divided by 5t to the fourth times cosine of t. Okay, so if you remember example 8, if you haven't checked that out, I recommend you totally check it out. But example 8 had a natural log, so we could use properties of logs to split it up. But cosecant, unfortunately, doesn't have any nice properties like that. So we're stuck with this nasty expression here. So we are going to have to do chain rule and then quotient rule and product rule also, all together in one example. So it is good to see ones like this because really, this function, you kind of got a lot going on here, but it's not really too nasty, I guess. It's kind of complicated, but these are nice functions, right? Cosecant, natural log, here's just 5t to the fourth, and then a cosine of t. Those functions really aren't that bad by themselves, but we toss them together, it's still kind of small, kind of compact, but the derivative, as we'll see, is going to be kind of a big mess. But anyway, let's just go ahead and do that. So we want to identify what's the little guy, what's the big guy. Start at any of the t's and just work your way out. Okay, here's a t, take a natural log. Here's a t, raise it to the fourth, and then multiply by 5. Here's a t, take a cosine, and then multiply by 5t to the fourth, and then divide natural log of t by this bottom here. And then after all that's done, then what you do is take a cosecant, alright? Take a cosecant. And then, yeah, multiply it by -1, but that actually doesn't really matter. Okay, because the biggest thing happening is the cosecant. And really, yeah, negative cosecant, I guess. But remember, this is like -1, right? So you could say -1 times all that stuff. And -1 is just a constant, so it comes out of the derivative. But anyway, s dot of t is going to be derivative of the big guy. So first of all, we have the -1 still floating around out there, so let's just put it there. Derivative of the big guy evaluated at the little guy. Alright, and what's the big guy? It's cosecant. Okay, the big guy is cosecant. So ddt, ddt. Let's say the big guy is -1 times cosecant. So ddt of negative cosecant of t is what? Well, this negative, remember the negative comes out, so it's -1 times ddt of cosecant of t. And -1 is still there. ddt of cosecant of t is negative cosecant of t times cotangent of t. Okay? So -1 times a negative actually gives us positive, so this is actually going to be cosecant of t times cotangent of t. Okay? So let's get rid of this negative then. Alright, this -1 up here. So our big guy is going to be negative cosecant. Alright? So if you want, you could just leave the -1 out here and then simplify it later, but it's going to go away because when we take a derivative of cosecant, we get another factor of -1, and those two factors of -1 multiply together to give us +1, so it's just going to go away eventually anyway, which is good. But anyway, derivative with respect to t of negative cosecant of t is cosecant t cotangent t, right? So that's our big guy is negative cosecant. So chain rule says do the derivative of the big guy evaluated at the little guy. So the derivative of the big guy is cosecant cotangent, but we want to evaluate it at the little guy, and the little guy is this mess in here. So this is actually going to be cosecant of the little guy, right? 5t to the fourth cosine t, and then times cotangent of the little guy. Okay, so that's from the chain rule, and then chain rule says multiply by the derivative of the little guy. Multiply by the derivative of the little guy. Ln t over 5t to the fourth times cosine of t. Okay, so that's from the chain rule there. So let's zoom out a little bit and just recap what's happened so far. So we've got all this. Okay, so we have here s of t is negative cosecant of this mess here. So the big guy is negative cosecant, okay? So the derivative of negative cosecant is cosecant cotangent, and the chain rule says derivative of the big guy evaluated at the little guy. Here's our little guy, so the derivative of the big guy, cosecant cotangent, evaluated at the little guy, is cosecant of the little guy times cotangent of the little guy. And then the chain rule says multiply that by the derivative of the little guy, right? So this is going to be a mess here. So, because this board that we're using here is not very wide, let's just look at this part by itself. Okay, so we're just going to look at that part by itself. So let's come down here in a different color. So we're just going to, so this, for the rest of the problem, these two, cosecant of that, cotangent of that, they're just going to stay there. So let's just look at this separately. All right, so let's come over here and write it, d dt of natural log of t over 5t to the fourth times cosine of t. All right, we can zoom back in a little bit too, I guess. Okay, we're going to have to do quotient rule, right? So the quotient rule says that the derivative of this is going to be bottom 5t to the fourth times cosine of t. Okay, that's our bottom times the derivative of the top. Okay, the top is natural log of t, so the derivative of the top is 1 over t. All right, so that's good. And then minus the top, all right, times the derivative of the bottom. All right, now we have to do the product rule. So the bottom is 5t to the fourth times cosine of t. The derivative of that, we have to use the product rule. The derivative of the bottom is going to be derivative of the first times the second. Okay, first is 5t to the fourth, second is cosine of t. So derivative of the fourth is, derivative of the first is 20t to the third. Okay, so derivative of the first times the second, so times cosine of t, and then plus the first times the derivative of the second. All right, the first is 5t to the fourth, and then the derivative of the second is actually minus sine of t. All right. So again, this was, all right, well actually before that real quick, all that is divided by the bottom squared, right? So 5t to the fourth cosine t, that whole thing squared, okay? So bottom times the derivative of the top minus the top times derivative of the bottom, and to do the derivative of the bottom we had to do product rule, okay? The bottom is 5t to the fourth times cosine of t, so the derivative of that is going to be what? Derivative of the first, which is 20t cubed, times the second, cosine of t, plus the first, 5t to the fourth, times the derivative of the second, minus sine of t. Right? So now, big mess here, so let's go ahead and simplify it. What's going to happen? What do we have? Let's zoom out just a tad. So here, 5t to the fourth cosine t times 1 over t. This 1 over t, what are we doing here? We're taking 5t to the fourth cosine t, and we're dividing it by a t. So this 1 over t is actually going to cancel with one of these factors, with one of these t's, and we're going to get t cubed up here. All right, that's good. What about over here? Nothing really canceling, but we could just simplify with a minus sign there, so let's go ahead and do that. And then we'll also expand the bottom just a tad. Okay, so equals, big line, 5t cubed cosine t, and then what do we have? We have minus natural log of t times, what's going on here, 20t cubed cosine t, all right, and then plus 5t to the fourth times negative sine t, so that means minus 5t to the fourth sine t, all right? And then all of that's being divided by, if we square this whole thing, 5 squared is 25, t to the fourth squared is t to the fourth times t to the fourth, which is t to the eighth. And then cosine of t squared is just going to be cosine squared of t, like that. Okay? So that's what's going on there. Now, is there anything else we can simplify? Yeah. Okay, so notice what's happening over here. Here's a 5 and a t cubed, and then here's a 20 and a t cubed, and then here's a 5 and a t to the fourth. So every term on the top, okay, this natural log of t, really, you could distribute it through to everything here. Let's actually go ahead and do that. So, yeah, it'll make the next step a little more clear. So this will be equals 5t cubed cosine of t minus 20t cubed cosine of t times natural log of t, all right? And then minus natural log of t times minus this stuff is going to give us plus 5t to the fourth sine of t natural log of t. And then all of that's still divided by the same stuff here. 25t to the eighth cosine squared of t. All right? So now it's a little easier to see. Every term on the top has a factor of 5t cubed in it, okay? Here's 5t to the third. Here's 20t to the third, which is really 4 times 5t to the third, right? And then here's 5t to the fourth, which is really t times 5t to the third, okay? So every term up here on the top has a factor of 5t to the third in it. So we can pull that out. We're totally out of room here, though. So let's go ahead and erase this here. So let's erase this too. Let's just work our way back up. Get a bigger board one of these days. Anyway, equals, so let's go ahead and pull the 5t cubed out. So when we do that, 5t cubed, what do we have left? Here is a cosine of t. Alright, what's left here? Well, if we have 20t cubed times cosine of t times natural log of t, if we pull out a 5t cubed, all these t cubes, they're all gone, right? But then here, if we pull the 5 out of the 20, then what we have left is a 4. Okay, so we have 4 cosine t ln t. Because remember, when we factor like this, you know, when we pull this stuff out, we're really dividing. So we think, okay, 20t cubed divided by 5t cubed just gives us a 4 left over, right? Just a 4. So that's the second term. How about the third term? Well, if we have 5t to the fourth, if we factor out a 5t cubed, in other words, 5t to the fourth divided by 5t cubed, what does that give us? Well, we just have a t left over. So that's going to be plus, because we have a plus sign here, plus t sine t natural log of t. Alright, and that's what happens on the top. And then on the bottom we still have 25t to the eighth cosine squared of t. Okay, so that's what's going on there. Now we can cancel some stuff. So 5 on the top, 25 on the bottom. Those are going to cancel, so 5 and 25 cancel. We're just left with a 5 on the bottom. T cubed on top, t to the eighth on the bottom. T cubed on top cancels with the t to the eighth on the bottom, and we're just going to be left with a t to the fifth. Alright, so that's great. Now this actually just equals cosine of t minus, let's go ahead and pull the natural log back out of here now. We don't really have to do that, but it's not a bad idea because it makes it a little more clear. Natural log of t times what's left over in here, 4 cosine t minus t sine t. Okay. So watch out, you know, we pulled out a minus natural log of t, right? So if we pull out the minus natural log of t, then there's no minus sign here anymore, and this plus sign becomes a minus sign. If you don't really like that, you could just leave the natural log still in here, that's totally fine. And then on the bottom we have 5t to the fifth cosine squared of t. Alright. So remember, this big old nasty mess here, this was what this is, okay? This is just for this. Okay, that's all this is here. And we still have to multiply by this stuff here. So when we write everything, let's go ahead and write everything out. Okay, now that we have it all. We're pretty much done here. Okay, the answer is going to be cosecant of this times cotangent of that times this mess here. But just for the sake of thoroughness, we'll write it all out. So cosecant of natural log of 5t to the fourth times cosine of t times cotangent of natural log of t over 5t to the fourth cosine of t times this big ol' mess over here. I have to rush a little bit because the camera is running out of batteries. Cosine of t minus natural log of t times 4 cosine t minus t sine t, and then all that's divided by 5t to the fifth cosine squared of t. So that's the derivative. This whole mess right here is the derivative of this function up here. All right, so let's zoom in a little bit on that just to get a clearer view. So s dot of t equals this whole mess here. And that is example 9 with the chain rule.